Hey, I'm Charles. I'm a full stack developer specializing in Python and React.
And my name is Israel Santana, but most people in tech know me as Izzy, and I focus on React and Spring Boot. And today I'm the host for the YouTube channel, my brother Charles, and he's gonna be teaching me some cool stuff. So I'm looking forward to it.
So today we'll be going over NGINX, the most popular web server, and three core use cases.
Okay.
So the first use case will be using it as a web server. So that's serving static files like HTML, CSS, JavaScript, and images, and doing that very fast. We also have using it as a reverse proxy. So that's so you can have multiple backends and have an NGINX direct traffic, setting up HTTPS and hiding implementation details from hackers. We will also use it as a load balancer to distribute traffic, ensure high availability, and scale horizontally. Scaling horizontally means we're increasing capacity by adding more servers. So NGINX is the most popular web server. It powers over a third of the internet, and it's used at some household names like Netflix, Airbnb, and GitHub. It's also open source, and it was invented by a guy named Igor who was trying to tackle the C10K problem, which is handling 10,000 concurrent requests on a single server, and NGINX blew it out of the water.
And it's crazy. He did that before ChatGPT.
Yeah, it's hard to imagine. So before NGINX was invented, everyone was using Apache and Apache HTTP server. And what it would do is it would spin up either a process or a thread for each connection, which introduces a lot of overhead and it makes it hard to scale. And it had blocking I/O, meaning you would have to wait for one operation to finish before starting another one. When NGINX came into the game, it introduced an event-driven, non-blocking architecture, which sped things up where a single process can handle up to like 1,000 connections, which made it very scalable. And it also has asynchronous synchronous I/O, meaning while one thing's going, it could do something else. Just one thing to note is that newer versions of Apache like addressed a lot of these concerns, but that'll be out of scope for today. This just shows how a traditional server like Apache could only handle about 1,000 requests on a single machine, while NGINX can do 10,000. So to make an analogy, it's like it would be really cool if you went into a restaurant and each customer got their own personal chef, right? But you'd have a problem when too many guests come and you simply don't have enough personal chefs, and it would also be very expensive to hire all those personal chefs. So NGINX is like having one master chef who knows how to do everything and can throw the chicken in the oven, and then while that's cooking, also chop up vegetables to save time. Does that make sense so far?
Yeah, it just makes sure it just creates an ability for software to be able to handle more requests than usual. That's where I'm at so far.
Yeah, yeah, definitely. So NGINX has some benefits. If one, since you're able to have multiple backends, if one server fails, it could just send them to a different server. Or if you need to take it offline to make an update, you won't have downtime because there's other servers available. Um, as you add more servers, the client doesn't change. It doesn't need to know what's going on behind the scenes. And you also have load balancing to prevent any one server from being a bottleneck. So the first use case we're going to go over is using it as a web server. You can serve things like HTML and CSS. By default for HTTP, it's port 80, and if it's HTTPS, port 443. You specify the root using the root directive. You can specify the base directory where your website is. Um, you can also define how URL paths are handled. So if, let's say you want to add a subdomain, you can do that. And you tell the browser how to handle each file type using something called MIME types, and that ensures optimal performance and compatibility. So let's jump right into it. Here we have a nginx.conf file, and that is the main configuration file for nginx. We have a server block where we tell it to listen on port 880, meaning it's HTTP. We specify the name of the server, which is example.com. Then we say where our directory is stored on the server. So we specify with root. We say, we define what happens when the user visits example.com without a specific path. By default, it'll go to index.html. Using the location block, we have something called try files, where we're saying, first, try when a user visits a specific path on the website, first try to treat it as a file. And then if that doesn't work, try it as a directory. And if that doesn't work, then we return a 404 not found error message. Um, we also to speed things up, we want to implement caching. So you don't want, let's say, for example, the logo of the website. That's unlikely to change very often. So here we're saying all the different file types that get cached, and this way, the every time the user loads the page, it doesn't have to like refetch that logo image. And we say that that'll last for 30 days using the expires. And then we're adding a header that specifies how the cache is controlled. We're saying it's public, so that means it could be cached at the CDN level or in other places. And we're also saying it's immutable, meaning it won't change during the direction of the cache. Now, this is all good, but you just got to be careful because sometimes you may make an update, and if it's within that 30 days, it won't immediately be reflected. So for that, you need to change the name of the file whenever you change it. So a lot of build tools like Webpack and Vite, they'll add a hash every time you change it so that everyone knows that it's now a new file and the old logo won't get returned. Another way to speed things up is with compression. So when we turn gzip on, we're turning on compression, and we're also specifying what files get cached. And this is usually good because if you have limited bandwidth or you have to pay for bandwidth, it saves on bandwidth. The only catch is it uses more processing power. So there's a trade-off. If you have a very big server that's very fast and you have limited bandwidth, then you want to turn compression on. If you have unlimited bandwidth, but a very small server that's not very fast, then you want to turn off compression. Compression is also good if you're sending data very far, like around the world, because it saves on bandwidth. Does that make sense so far?
Yeah, yeah.
Awesome. Our next use case is using it as a reverse proxy. So You may have heard of normal proxies where the proxy acts on behalf of the user. So that in this case, where it's a reverse proxy, meaning it's on behalf of the backend, meaning the client only talks to NGINX and they have limited knowledge of the actual backend itself. So like its implementation details are hidden. And we're also defining HTTPS here. So all the SSL certificates are all managed by NGINX, and this is actually good for performance on your backend. The backend only needs to work with HTTP when talking to NGINX, but the connection between the client and the NGINX, that's all HTTPS. And also we can there's a single entry point to all of our backends. So that really simplifies things. Because if you make a change, all the changes that are done to the underlying configuration are all invisible to the user. So here we have an NGINX config file where we're doing both the reverse proxy and load balancing. So we're defining a block of servers where we implement load balancing with least connections. So that means it'll always get the user will get sent to the server that has the least amount of active connections. The alternative that we could have done would be to use round robin, where it's just dividing it equally. We also are saying that this first server with a weight of 3 means it'll be used 3 times more often than the rest of them. And then that last one that has backup is only used when the other two are offline as a backup. Then we have the server block, and we're listing on port 80 like before we name it, but we're specifying that it gets routed to that backend service block that we just talked about. So that's where that gets called upon. And we're also passing some information about the client to the backend, like their real IP address and the forwarding chain. Um, does that make sense so far?
Yeah, yeah.
Awesome. So, mastering these three things are really going to put you ahead in the game. It's very helpful to know as a backend developer. And of course, this is only just scratching the surface. There's a lot more to learn. And thanks for watching.
Yeah. And one of the things that I wanted to ask, so let's say, for instance, me, this is the first time I ever seen NGINX. So how this connects to someone working with Express.js? And
So
that, yeah.
you wouldn't, so when you're working with Express locally on your computer, you would have it exposed to port 3000 and you would have your client connect to port 3000 and that's it. But putting that exposed to the wild west of the internet is not a good idea for many reasons.
Hmm.
The first is just that it's completely exposed. You're not hiding any of the under like any of your configuration from the user. Like anyone knows exactly where your backend is and can just do whatever they want with it. With NGINX as a reverse proxy, they're only able to talk to the reverse proxy and they're not able to access the server itself. Another thing is you won't have load, well, you can have load balancing using something like AWS where you can pay to have a load balancer, but if you use NGINX, you have a free load balancer to distribute the load across multiple servers. Um, And what else? You can set up HTTPS with Express directly, although I wouldn't recommend it. And yeah, those are just some reasons you would want to use that. But like before, we have things like we could turn on compression, we can implement caching policies,
Yeah.
and I'm not really doing it justice, but there's a whole lot of features.
You know, it really got my attention. The default local port, which is 80. So at first when you showed it, I was like, oh, he forgot to say 80 again because I work with Java and Spring Boot, and every time I run the backend, it usually goes to the 8080 port. So I I was surprised when I was like, oh, it literally just 80. So that was cool. And then I love I think it's the next slide in where it shows the um, part 3000, and then if it fails, then run this one. If not, it runs the backup. I love, yes, that one. So that was very cool, and I was very if you work with Express or you have built servers, as soon as you see this totally makes sense. So it was kind of cool to see it like in its and is a in a basic form, but it's so powerful. You know, if we do it three times, if now we go to 3001, 3002, and that's just a simple example. I can imagine that you can put a lot more servers, right? And just
An infinite amount, essentially.
yeah. So this was fun, my brother. Thank you so much. I've learned a new thing. I again, when you told me about this, I had no idea what NGINX was, and now I'm more familiar. And again, it's just crazy now that we're in a era of AI. So it's like somebody wrote this and created this, and this individual had no how you call it, no resource to do this. They just did it. So thank you again for giving me a quick breakdown of this.
Of course. It's funny that you mentioned the 8080 thing because it's not just NGINX where 80 is the default. Like if you w when you open up a browser and you type in google.com without specifying a port in the URL, by default you're connecting to 80 if it's HTTP and then 443 if it's HTTPS. Kind of like with SSH, it's the default is 22. There's just kind of like some standards that and NGINX complies with that. I imagine when they came up with the 8080, it was just kind of to 80 was taken by this, but they wanted something familiar, so that's why they.
Oh, hey, that makes sense. That makes sense. But yeah, this was fun.
Yeah, thanks for having me.
Oh, good, my brother. Looking forward to seeing this on your YouTube channel. And yeah, I got something new that I learned on a beautiful Saturday.